Yeah, so based dun sa poll, majority naman is majority naman sa inyo is tapos na sa week 1 exercises. Hopefully, okay lang. Okay? So, halos lahat sucks lang sa exercises. Hopefully, hindi pa kayo masyadong nahirapan doon kasi, well, baka mas mahirap yung mga susunod. Although, ayun, magiging less naman about programming yung future exercises and more on analysis na siya. So, yeah, hopefully dumali sa inyo. Yeah, so medyo masakit na lamunan ko. So, hindi ko alam kung hanggang saan naabot boses ko today. So, let's go. So, ayun. So, down pa rin ng uble. So, which is primarily why nag-opt akong mag-synchronous session today para lang at least mag-guide kayo ng slight since wala yung value academics natin. So, hopefully, nakita nyo na yung link to our drive ng weekly resources. Actually, uploaded na hanggang week 7. So, although for some weeks, hindi pa yata naka-upload yung assessments. So, although for week 2, yung OVLE quizzes nyo naman is may PDF form sila. Itong dalawa over here na pwede nyo lang sagutan on your own and then plug in na lang yung sagot nyo when OVLE is back up. Or otherwise, if maging super inconsistent na OVLE, we might look for an alternative platform. Okay, without further ado, for week 2, ang focus is on or yung introduction na sa analysis of algorithms part ng course. So, in particularly, ang itatakil ay algorithm complexity and even more specific yung runtime complexity. So, basically, we can have two algorithms doing the same thing, pero how do we know which one is better? So, ito yung pinaka-introduction natin to that part. So, for the week, meron kayong, three activities. Well, yung first two ay yung materials and then yung last yung assessment. So, activity 1 is big O, or basically ito yung notation na ginagamit natin to describe yung runtime complexity. Now, merong lecture tsaka handouts na binigay sa inyo. Nandito siya sa lecture materials dito. Although, mas sanay kasi ako doon sa slides ko na ginagamit ko before. So, I guess daanan ko lang to ng pahapyaw or medyo madali. Basically, same lang naman yung sinasabi. Mostly, mas gusto ko lang yung slides kasi siya yung, yun yung masanay ako yung flow. So, yeah. So, basically, ang topic is on algorithm complexity. So, why study algorithms? Kasi they found out na even if we get faster and faster GPUs, CPUs, processors, etc., lalo na ngayon, mas marami tayong nakukuhang benefits for faster algorithms over faster hardware. Kasi yung faster hardware natin will be limited in terms of physical properties. Pero, ayun. So, of course, maganda if we have both. Pero given the choice, usually, mas magandang hardware, mas mahal, mas magastos. So, usually, mas tinitignan is better algorithm implementations na lang. So, to just give a formal definition ng algorithm, it is a process or set of rules to be followed in calculations or problem-solving operations. So, hindi lang actually ito nag-apply sa computers. So it can actually apply to real life. For example, making coffee. Well, depende sa way of coffee mo. What a French press. Then you put your ground. First, kailangan mo i-grind yung coffee beans mo. And then lalagay siya doon sa lalagyan. Tapos ipipress. Ay, lalagyan ng mainit na water. And ipipress. And then lalagay sa cup. So, parang set of steps siya. Basically. So, in analyzing algorithms, usually may two parts. So first is the algorithm correct? So tama ba yung ginagawa ng algorithm? And you will learn more about this in the following weeks. Pero for now, focus natin is how much resources does the algorithm need? For now, ang titingnan natin is time, or how much time yung kailangan hintayin bago matapos yung algorithm. Although there are other resources na kino-consider like memory, pero for now, yung mga tinitingnan natin algorithms, they don't use as much memory. So we don't really focus on them right now. So runtime analysis, so yung actual na running time ng isang algorithm depends on a lot of things, such as yung CPU speed mo, yung available na resources, kung saan mo siya kinompile, anong programming language yung ginawa mo, and then yung coding efficiency mo rin as a programmer, kung marami kang unnecessary steps na nilalagay. Kuwari, naglagay ako ng pan-debug, of course, nagtitake ng extra time yung ating program to print out yung debug na messages natin. So, kaya, it is impractical to implement an algorithm to justify its use. So we need a way to analyze the running time that is not affected by these various factors. So kailangan natin, since maraming nag-a-affect ng actual na running time, we need to look at another thing para ma-compare natin accurately ang different na algorithms. So doon pumapasok yung tinatawag na time complexity. So notice na dito pinag-uusapan is running time or runtime. Dito is time complexity. So basically tinitignan natin how 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 our input affects yung time complexity ng output basically. So parang sinasabi lang nito, if increase ko by if i-increase ko by this much yung aking input, how much time does that add? So for example, nag-add ako ng kung ano yung input ko has a size 10, it takes 100 seconds. If gawin kong 100 yung input ko, will it take 1,000 seconds, 10,000 seconds, or maybe mas mabilis siya apparently, pero wala namang mangyayari. Although, yun yung tinitingnan natin sa time complexity. So, how much does the program runtime scale with our input? So, yun nga, since yung growth, or yung paglaki ng time yung tinitingnan natin, yung actual na time doesn't really matter for us. Although, yun nga, it will only make sense if our input is large compared dun sa other na constant na factors. Kung may something na super bagal to begin with. For example, when you run a program, mabilis mag-run yung algorithm mo, pero the way you output that to the world, kunwari, algorithm siya that controls a motor, kung mabagal mag-start yung motor mo, parang wala na ring effect kung mabilis yung algorithm mo kasi hinihintay mo mag-start up yung motor, for example. So, how do we compare this time complexity? So, for example, here, we have a algorithm that adds up the contents of an array. So, as you can see here, pag yung itong input size, it means how many elements does are half. So, if nasa 300,000 yung elements, yung runtime niya is nasa around 0.6 milliseconds. Pag umabot ako ng 40,000, nasa 0.8 milliseconds siya. So, graphing it out, you can describe it as a linear na time complexity kasi it forms a line. Now, in this other example, instead of adding all the elements sa array, 10 elements lang yung ina-add ko. So, even if malaking input ko, since 10 elements pa rin yung ina-add ko, yung runtime ko remains the same. So, in this algorithm, we say yung time complexity niya is linear with respect to dun sa input size. And dito naman is constant siya with respect to the input size. So, of course, looking at the code itself, paano nga ba natin makukuha or kaya ba natin i-predict yung ating running time without actually calculating? So, looking here, meron tayong dalawang running times. So, for the first function, let's say n squared yung running time niya. For the second one is n squared minus n plus 2. So, if tingnan natin sila at small inputs, minsan, at the start, mas malaki si g of n, tapos at the end, mas malaki si f of n. But if we increase the input size significantly, almost wala na silang difference. So, parang hindi na nagmamatter si minus n plus 2. So, g of n approximately looks like n squared. And then here, for example, gawin kong n to the 6 si f of n. Si g of n ay n to the 6 plus other stuff. Kahit tanggalin ko yung other stuff, parang pareho pa rin yung itsura niya. Then, if I, for example, have 2n squared, parang sinusundan niya pa rin yung shape. So, actually, ang naging important lang sa atin is yung fastest growing term. So, tinatawag dito is yung asymptotic na behavior, which means na yung running time natin is sort of follows an asymptote. Yeah, asymptotic. So, lagi siyang malapit dun sa asymptote, kahit hindi siya exactly equal, it gives us a good representation ng running time, even if hindi natin makuha yung exact na running time. So, I think unstable the internet. So, okay na ba? So, even then, ayun, ang kina-consider lang natin is yung fastest growing term. And then, we can even ignore yung coefficients ng fastest growing term. I think doon naman sa lecture na given sa inyo is mas nabibigyan ng detail bakit pwedeng gawin ito. Then, hello? So, I think online na ako ulit. Sana not converge. So sorry about that. So when we talk about the time complexity, ang tinitignan, we usually look at 3 different cases. So first is yung best case analysis, then yung average case, and then yung worst case analysis. So, syempre depende sa input natin, hindi naman always pare-pareho yung runtime niya. There are cases na mabilis siya mag-run, and there are cases na matagal siya mag-run. So ang main focus natin would be yung worst case analysis. Since pag nakuha natin siya, at least alam na natin up to how long it will take. And usually yun din naman ang gusto natin tinitingnan when we implement this in practice. So mahirap yung mag-implement tayo ng something na maganda yung best case, pero baka madalang lang mangyari yung best case. So at least kung yung worst case natin is at a good level, parang in general, mas maganda yung ating program. So, yung average case analysis naman, it takes some statistics. Although, even though pinakamaganda talaga tignan yung average case analysis kasi masyadong pessimistic yung worst case. Medyo outside the scope na siya ng ating course. So, yeah. Yung worst case analysis is also sometimes called the big O notation. And then yung best case is omega. So for the big O notation, siya yung worst case time complexity. And siya yung pinaka-upper bound natin ng tinatawag na scaling. So, ayun. So yung typical big O na functions, since remember na usually strip off natin yung mga lower terms, so yung mga usually natitira is, for example, O of 1 or constant, logarithmic O of log of n, linear O of n, log linear O n log n, and then ito, quadratic n squared, polynomial n to the k, exponential 2 to the n, and then yung worst of all, si factorial, which is n squared. So this tells us yung parang scaling ng ating input. Yung scaling ng ating running time in terms of the input. So, for example, meron tayong, I guess, input na n equals 10. So, for constant runtime, constant pa rin yung output. So, for logarithmic, log of 10. So, since mahirap mag-type. Pag linear, for example, magiging 10 seconds, for example. Pag log linear is 10 log 10. Pag quadratic, magiging 100. N to the k, so 10 to the k. Pag 2 to the 10, that's 1024. Pag n factorial, that will be some large number. So, basically, dito pa lang kita mo na kung alin yung malaki or maliit. Now, if we move on to n equals 100, ito is magiging 1 pa rin. Yung n is magiging log of 10 or log of 100 pala. So, let's say maging log base 10 to. Ito is magiging 1. Ito is magiging 2. Tapos pag linear, magiging 100. So, ito initially 10. Ito we'd expect to be 10, 200. Then, ito is magiging 4 zeros. Oops. So, I guess you should see the point na gaano kalaki yung pagbabago between yung n equals 10 to n equals 100 to n equals something else. So, essentially, pinakamabilis magbago yung factorial and actually, hindi talaga nagbabago si O of 1. So, yung ating big O functions or kung ano man yung big O no ating implementation, it tells us how worst it could get for the algorithm. So yung guidelines to analyzing your program time complexity, yung basic operations natin, usually take constant time. So assignment, addition, subtraction, etc. And then yung sequential statements natin, nag-add up sila. So let's say, assign ako ng A equals temp, tapos nag-compare ako between A and B, tapos inassignan ko ng value of temp. So each of those steps ay each of those steps take constant time. So when we add it up, magiging O of 3. Pero since yun nga, asymptotic notation tayo, we don't really care about the coefficient. We just say it's O of 1. Now, kung meron tayong if-else statements, yeah, so we first get yung running time ng test condition natin, and then we get whichever is yung maximum between doon sa body no if or yung sa body na else. So basically magiging ganito yung itsura niya. And then for loops, we usually get yung kung ano yung running time nung nasa loob ng loop, and then multiply it by the number of iterations doon sa loop. So for example, itong inner loop, well, yung body niya is just an addition operation. So O of 1, assuming na yung access natin dito sa math object na to is constant din, we repeat it at least n times. So itong loop na to will be O of n. Now, itong O of n na to, nasa loob siya ng another loop that repeats n times. So yung O of n, mamumultiply siya ng n. So magiging O of n squared. So, ayun. So, actually, lumalaki lang naman yung ating running time usually pag merong loops. If wala namang loop, most often than not, constant lang yung running time. So, some properties, if mag-add ako ng dalawang runtimes, usually we just get whichever is bigger. Now, if nag-multiply ako ng dalawa, we actually multiply kung ano man yung running times nila. So parang simplification lang, whenever we add stuff, since asymptotic notation to, we get yung maximum or yung fastest growing term. So here, another example. So mag-start tayo, well, usually you can start at the outermost loop, pero ako mas gusto ko yung magsa-start sa innermost. So sa pinaka-loob, this is just O of 1. And then this loop runs for j number of times. So, O of 1, multiply ko by j. Although, si j, dependent siya sa value ni I. And si I, dependent siya sa value of n. So, at the worst case, si j will be equal to I minus 1. And at the worst case, I minus 1 will be equal to n minus 2. Or essentially n, since asymptotic naman tayo. So we can say na kahit hanggang j to, si k, we know that si k, ang maximum na magiging value niya will be approximately n. We can already say na multiply ko na lang na n yung value na to. So for this loop is O of n na siya already. Then for this loop, yung O of n, multiply that with the number of times, which is n then. So magiging O of n squared. And then yung outermost loop naman natin, big O of n cubed. So yeah. So limitations ng big O. So overestimation siya usually, and yun nga, worst case running time siya. So the average case running time may be significantly less than the worst case running time. So if yung worst case nyo, hindi naman siya usually nangyayari, it might not actually be that good of a measure. Pero yun nga, because average case is extremely hard to, or extremely complex, yung best tool we have is this big O analysis. Okay. So that covers yung first activity. And then for activity 2 is yung sorting algorithms. So you can go dun sa lectures here. Pero ako, to visualize yung sorting algorithms, I usually go dito sa visualalgo.net. And then you can try this module, sorting. So for example, bubble sort, then actually, ano ba to? Yeah. Sorting. So what bubble sort does is basically nag-bubble up whichever's the bigger. If mag-compare siya ng dalawang adjacent elements and mas maliit yung nasa kanan, basically magsa-swap sila. So for example, ayan, if we compare 44 and 38, since mas maliit si 38, ilalagay niya sa left, and then go to the next pair of elements. And then next pair. So basically, ang makikita nyo dyan is whichever is the biggest element, parang nagbo-bubble up siya. So, pag tuloy-tuloy lang dyan. So, what it appears to do is pinipick up natin yung largest element na nadadaanan natin. Tapos, ayun, whenever we find a larger element, yung larger element naman yung parang ipipick up natin and ibabubble pataas. So, so basically, that's bubble sort. Now, to analyze yung bubble sort, we can look at the worst case, wherein we almost always need to swap, which is pagka-reversed order. So basically, when we sort it, kailangan natin daanan lahat ng elements. So, yung maximum number of swapping. So, ano yung worst case running time niya? So, usually yung nga, titignan mo yung mga loops. So, going over yung pseudocode ng bubble sort over here, we have one outer loop, and then we have an inner loop na starts from left to right. So, yung inner loop natin, yung sa loob niya is a conditional statement na either magsaswap or hindi magsaswap. So, assuming na yung swap natin is O of 1, and then ito, at worst case, so from I to last index no unsorted, at worst case, it's the size of the list, which is n. So yung loop na to is O n. Then yung outer loop, hanggang ilang times magra-run yung outer loop. So, looking at the worst case ngayon dito, the maximum number of times na kailangan mo siyang ulit-ulitin is actually the number of elements doon sa list. Which is yung case na parang one at a time lang nagkakaroon ng nasasort yung nasa right side. So, since O of n yung nasa loob, tapos n times yung sa labas, bubble sort at the worst case is O of n squared. So, next naman is yung selection sort. So, what this does is, instead of mag-swap, hahanapin niya na lang talaga yung, in this case, yung smallest element, and lalagay niya siya dun sa first index. And then yung next smallest element, lalagay niya siya sa next smallest na index. So, from the name of the algorithm itself, selection sort, sineselect natin kung ano yung next element doon sa ating sorted na list. And you'll notice, ayun, parang meron tayong sub-list dito ng sorted na elements. So, basically, yun yung tinatry natin punuin. And pag napuno na yun, nakuha na natin yung sorted na list. So, yung time complexity nito, since you need to, well, ito, yung inner loop natin is finding yung minimum doon sa list ng unsorted na elements. So, since kailangan natin daanan each element once, yung running time ng inner for loop natin dito is O of n. Then, we need to repeat it by the number of elements doon sa list. Since kada hanap natin ng minimum element, we get one more item doon sa sorted na list. So, to complete it, kailangan na lahat. So, at worst case, or actually kahit best case actually ng selection sort, this is actually O of n squared. Now, next yung insertion sort over here. So, what insertion sort does, so parang you assume that yung you assume that your left sub-array is already sorted. So, yung sa initial case na may isa ka lang element, so, ayun, sorted siya. Then, you get the next element doon sa unsorted na partition. So, let's say, I think better if dito tayo sa gitna. So, yung part dito is sorted. And then yung part dito is unsorted. So what insertion sort does is kukunin niya kukuha siya ng element doon sa unsorted list and then i-insert niya siya dito sa sorted list na to. So basically kailangan niya lang i-compare saan niya dapat i-slot in si 26 dito sa sorted na list. So basically hahanapin niya lang yung tamang pwesto niya and then i-insert niya siya doon. So, hopefully, hanggang daanan niya lahat ng elements doon sa unsorted na part is ma-insert niya doon sa sorted na list. So, ayun, as a sort of analysis, yung running time niya is yung innermost loop is finding the correct position doon sa i-insert natin na element. So that is precisely yung worst case nun, yung last case. na kailangan natin i-compare sa madaming elements. So, for example, gusto natin insert si 19 dito sa list na to. We check isa-isa kung mas malaki na ba yung, or mas maliit na ba yung katabi niya. So, yung first instance na mas maliit yung katabi niya, which is 15, doon na papasok si 19. So, at the worst case, kailangan natin i-insert yung element doon sa pinakaumpisa. So, that would be O of n. And then, para daanan natin lahat ng elements dito sa list, para i-insert dito, that is n more times. Ay, n times natin gagawin yung paghahanap ng tamang position. So, effectively, yung worst case ng ating insertion sort is O of n squared then. So, ayun, lahat ng sorting na i-introduce so far will be n squared. So, ayun, you'll know in the future. And so different algorithms, same result. And in terms of time complexity, mukhang pare-pareho sila ng worst case. So, kailan gagamitin yung isa over the other, it will depend doon sa actually sa operations na pwede mong gawin. Notice na si bubble sort, madami siyang swapping na ginagawa. So what if yung swapping operation ko is not constant? So hindi favorable yung paggamit ng bubble sort doon. And then yung sa insertion sort, yun, what if mahirap sa'yo mag-compare ng elements? And ayun, so basically, we look into other stuff instead of just yung running time, or basically kailan ano yung mga specific steps or actions na ginagawa ng algorithm that might be slower in some implementations over other implementations. So yeah. So those are yung sorting algorithms. And you can actually look at yung other sorting algorithms dito. For example, for merge sort. So, kung gusto nyo, pwede nyo i-analyze ano yung hula nyo ng runtime niya. And then, so basically, kayo na bahala doon. Pero for now, yung covered lang naman is yung bubble, selection, at saka insert ata. Not sure if meron pa. So, after nun, sorting algorithms quizzes na. So, you have two required activities or assessments, which is yung assessment quiz tsaka yung big O na problems. You can find them here habang down si uli. So, basically, kailangan nyo lang naman i-calculate yung big O ng mga given na functions dun sa big O. And then sa quiz is more of multiple choice. So, choose the best answer given yung question and yung choices. Then, sa Discord, hopefully nandito na kayo lahat, nag-send ako ng since nag-handle na ako ng course nito before, I actually have my own set of exercises for it. Kaso in C++. So hopefully magets nyo pa rin. So ang main difference lang naman dito is yung for loop, iba siya sa C++. So yung for loop, pwede mo siyang i-dissect into 3 parts. So pwede ko siyang ihiwalay, int I equals 0, tapos while I less than x, Then sa loob ng while yung I++. And then yung I++, this will be the same as I plus equals 1. Tapos ilalagay ko lang yung contents ng loop dito. So basically, these two loops are the same. So, walang important lang naman dito is yung conditional for now. So, basically ito, nag-increment lang yung naman ni sum for x times, depende dun sa input. So, you can say na yung dito sa loob, of 1, and then ilang times siya inuulit, x times. So, x times O of 1. So, yung loop na to is O of x. Ngayon, yung big O naman natin, usually O of n yung ginagamit because n usually means yung size. Pero you can also use another variable for this example, x. So, since yung loop lang naman yung main contributor ng running time, dito na yung pinaka-running time ng function natin. Okay, so tama na ba yung nakashare? Sorry. Nagmamadali ako mag-screen share kanina. I think mali na pindot ko. Yeah, so I guess ulitin ko na lang. Since C++ to, medyo iba yung itsura ng mga loops. So, hopefully maintindihan niyo pa rin. Yung for loop na to is just yung while loop lang siya sa Python with extra steps. So, basically in a single line, ginawa mo yung initialization and nilagay mo yung condition. And then yung update niya rin is nilagay mo sa loob. Yeah. So basically yung dalawang loop na to will do the same thing. So yung for loop kasi sa C++, basically yung initialization at saka yung update is pinagsama siya sa isang line over here. So yung pinaka-important lang naman dito is yung conditional since it tells us how many times do we repeat the loop. And then yung update din kung +1 lang siya. And then yun din pala, ang plus is pareho lang sa plus equals 1 ng Python. So shortcut siya sa C++ since sobrang dalas mo gamitin yung pag-increment by 1, may special siya na operator. So, ayun. Ang analysis din naman will be the same. So, yung pag-increment ng sum is a constant operation, so O of 1. And then, since nasa loob siya ng loop that starts from 0 and ends at I equals, I is less than x. So, you iterate ng loop x times. So, may O of x siya. Now, since siya lang naman yung loop dun sa function, siya na lang halos yung tinitingnan mo. So, double check mo na lang yung other stuff kung constant. So, since constant lang naman, yung function itself will be big O of x. Dito sa function 2, yung nasa loob is a function call to function 1. So, hindi na siya O of 1. Magiging O of function 1 given yung input na I. Now, at worst case, ano yung worst case natin? I is equal to x over 2. So, if I is equal to x over 2, yung big O natin dito sa loob will be O of, since si function y ay O of x, ito ay big O ng big O of x over 2. So, which is just O of x over 2. Or just x. And then, since nasa loob pa siya ng for loop, na mag-uulit x over 2 times. So, x over 2 times O of x. So, magiging O of x squared si function 2. And then, ayan, dito sa baba, may if statement ako dito. Either go here or either go here. And remember, pag sa if-else na statements, we usually look into yung whichever is the larger one. So, since we know na si function 2 ay x squared, si function 1 ay O of x lang, ito yung mas magdodominate. So, siya yung magdidictate no running time no algorithm dito or yung body ng loop. So yung body ng loop is predominantly this one. So, magiging running time mo dito is x times big O of x squared. So, magiging O of x cubed. So, yun na naman. There are rarely parang madalang lang naman yung ways na lumaki yung running time ng hindi gumagamit ng loops. Yung mga mahirap lang i-catch, I guess, pag gumamit ka ng function, you have to take into account yung function mo, kung ano yung running time ng function na kinakall mo. Now, for example here, ginawa ko tong I times I. So, yung magiging running time dito would be O of ano man yung running time ni function 2 with I times I as an input. But remember, yung worst case natin ay is magiging equal siya kay x. So, magiging sa function 2 pala. So, magiging equal siya sa x. So, magiging x squared to sa loob. Eh, si function 2, O of x squared siya. Pag yung input ko ay x. So, pag ang input ko ay x squared, ito ay magiging x squared squared. Since yung function call ko here calls at the worst case x squared yung value sa loob. So, yung worst case running time natin will be yung x squared. Pero si x is magiging, or to be clearer, magiging I to, I squared. So, magiging I squared squared. So, hopefully nasundan nyo yun. So, since I squared yung input kay function 2, yung magiging running time niya is I squared squared. So, magiging O of I to the fourth. Pero at the worst case, I is equal to x, so may x to the fourth siya. So, ito may x to the fourth. And then, ayun, ito ay x to the 5. Pag ginawa kong I times I, yung dito sa loob. So, marami yung examples dito. And then, yung answer key naman is binigay ko rin dito. So spoilers. Ayan, naka-breakdown naman dito yung running times. And yung final answers ay nandito sa taas. So, ayan, if you have any questions dyan, discuss lang natin over or comment lang kayo sa Discord or send me an email. And basically, that's it for this meeting. Meron ba kayong questions? Hopefully, hindi kayo masyadong na-bother. Nawalan ako ng internet. Wala naman questions. Ayan, so if wala nang questions, that's all for today. Hopefully, may natutunan kayo and hopefully nakatulong siya for your week 2 activities. And so, yun. Magandang hapon. So,
Okay. End na yung meeting.
yeah.